Hello, my name is Raz Kupferman. I'm a professor of mathematics in a university, and I'm one of the founders and the chief scientist of the education technology company Matific. And today we are going to learn here about game-based learning. So let me show my presentation. That's the end. We will start from the beginning. So that's the title of my lecture, how to unlock the power of play and how game-based learning can really make a transformation in the way we teach and learn mathematics. So there's so much buzz nowadays about games, gamification, game-based learning, and people are all over talking about its many advantages in increasing the engagement of children and reducing anxiety. But whenever I hear the word engagement, my first question, automatic question is, in what do we want to engage children? So let me be very, very simplistic for just a moment and imagine a simple world of good and bad. And suppose we have good content and bad content, which is within a good game and a bad game. And question number one here is, where would we like to be? It's not a trick question. I think we all would answer that, yes, very good content in a very good gamified environment would be perfect. Great. What about the second place? Okay, what do we choose? So we are educators. So of course, first of all, we need good content. So that's another easy answer, actually. Okay, bad game, not a catastrophe. We want good content. And then, of course, the third place would go to the good game with the bad content, right? At least one good thing. But really, I mean, do we want to engage children with bad content? Whenever I hear engagement, another reflex I always have is to remember that there's nothing more engaging than gambling applications and gambling games. So engaging could be also bad. So the connection between game-based learning and education is actually not that simple. Okay, I think we have a lot to gain from game-based learning, but we also have maybe a lot to lose. And I want to start by highlighting some of the drawbacks, actually potential drawbacks of gamification. First, screen time. Do our children need even more of that? Probably not. Engagement also comes sometimes with distraction, which is a negative aspect. If you're engaged in doing something which actually is wrong, you may consolidate misconceptions. Rote learning, one of the big problems, I think, in math education, which is overemphasized. And many of the gamified applications do actually more on that, on turbo. And finally, a lot of games are competitive, while some children find engagement in competition. For other children, it's actually unfavorable. And as we know, very often it's gender biased. So actually, now I think I come to the real title of my lecture, how to extract the benefits of game-based learning while avoiding the potential drawbacks. And all my lecture will be through examples that will be taken from the Matific platform. And the way I will do it is I will address three main pain points in math education and discuss them and show examples. So the first pain point is that math is boring. I'm a mathematician, so math is not boring. And yet we know that the majority of children, but also the majority of adults, think that math is very boring. The adults may tell you maybe that math is important, but boring. So still today, the majority of the resources are based on standard worksheets, like word problems, like Julia made a necklace and a question on beads, or maybe marking all the right triangles in this picture. and mostly arithmetics, things like that. Okay, worksheets and worksheets of arithmetics. And it doesn't work. It doesn't work in many aspects. First, it puts a lot of emphasis on one thing or a small group of things which are not that important, okay? And it gives the false sensation that this is mathematics. And also it doesn't work because most of what we learn is quickly forgotten. How many adults do remember how to divide fractions or what it even means to divide fractions? And that's where the ed tech industry came in. If this doesn't work, that would be the solution. Do it on a computer or a tablet. And if that's not good enough, we can improve it here. And maybe we can improve it even further like this, feeding virtual kittens. So yes, it's not a joke. There's actually a platform in which for every, I don't know how many worksheets you solve, you get to feed your virtual kittens. I didn't check it, but maybe the kittens die if you don't do enough math. So gamified worksheets are very, very easy to produce. And you can do tons of them. Some of the platforms advertise something like 150,000 different worksheets, and they're automatically verified. However, okay, using them excessively first send a very clear message. Math is boring. And therefore, we need to sugarcoat it with pictures of dragons or feeding virtual kittens. It also tells the children that actually this is mathematics, which from my point of view as a mathematician is horrific. We're also being dishonest. We're trying to tell our children that math is interesting, but then we don't believe in that, right? Which again is why we needed to sugarcoat it. And finally, even that doesn't work. Gamification is not the same as game-based learning. And if I were to say in one word, what's the difference? So gamification, the mathematics, is incorporated in a game. Whereas when I think of game-based learning, mathematics is the game. And that's the time to go to an example. So let's take something from an early grade where children have to learn addition and subtraction and use a number line model to visualize the operations. So that would be a standard worksheet. I'm not saying it's evil, okay, but what I'm saying is that we can do much better. So that's an example of a game. So let me describe the game. What you have here is a rail with number holes and numbered holes. There's a monster waiting under hole number 14. There's a cookie just above hole number 9. And there are springs that we can place on the rail with numbers that tell us by how many notches the cookie will hop forward or backward. And our goal is to feed the monster by placing the strings and releasing the cookie. So for example, if we place those two springs, the cookie will hop 3 forward, and fall in hole number 15. So the monster will not get the cookie, and the monster will be upset. And that's a correct solution. For example, 8 forward, 6 backward, 3 forward, and right into the monster's mouth. But with the same springs, we also have another solution of 3 forward, 6 backward, 8 forward, hop to the monster. And yet another solution by first going 6 notches backwards. All right, so some reflections about what we've just seen. First, I hope it's very clear that the game is the math, okay? And that's what I call game-based learning. Secondly, making errors is funny. The monster is upset. The monster tells you you have to correct, and it's amusing, not threatening. But making errors is also instructive because you're not told that you've made a mistake. You just see the cookie falling in the wrong place. And therefore, you have a start of, okay, I have to correct it. I went one too far or too early. So how do I correct it? This game becomes very quickly a multi-step and multi-level game, which is another great advantage. It evolves, something happens. You have the opportunity to explore multiple solutions, something which I think is overlooked very often in math education. There's not only one correct solution. And finally, aha moments. For example, a child through the game can discover that it doesn't matter in which order I put the springs once I chose them, okay? Because adding and subtracting are commutative operations, okay? Add 3, then subtract 4 is the same as first subtract 4, then add 3. Something to discover. And that brings me to the second pain point, math anxiety, a real problem internationally, not only in your own country. I think there are many reasons, I think, for anxiety, math anxiety, but one major cause is, I think, a lack of preparedness. What happens is that children need to rapidly assimilate new concepts. They have to assign meanings. Okay, for example, a fraction, what does it mean? Also, representations. All of a sudden, I have these two numbers that are made of two numbers, one above the other. And what happens when things come up too fast is that children adopt a survival mode. Okay, at some point they say to themselves, okay, I don't need to understand anything. I just want to tell me how to do it correctly. That's what I want. And it happens often very, very early. So let me actually start with an example where children are well prepared, counting. Okay, so children are exposed to numbers, counting, and comparison from a very young age. I remember my own children, when they just started to walk, I would hold their hand and I would count with them aloud steps, or counting chickpeas, counting objects. And throughout their preschool years, they're exposed to so many opportunities, all those counting books and counting videos and counting songs. It's all over. And once they came to school at the age of 5 or 6, they actually, most of them, have a fairly good understanding of numbers, quantities, the notions of more, less, equal. And when they come to school, that's what they do. That's mostly what they do in the first year. They consolidate this informal education they've earned at home. And in comparison to that, let's talk about fractions, which is probably one of the big traumas of every child. So what I'm showing here is the grade 1 curriculum in the US, the Common Core. In grade 1, the only thing children are expected to learn is to partition circles and rectangles into 2 or 4 equal shares and use the words half, a quarter, or a fourth. Grade 1. Grade 2, it looks almost the same with one difference. Also partition into 3 parts and use the word a third. And that brings us to grade 3. You don't have to read all this, okay? But there's a lot happening. Understanding the 1 over b as a fraction and the a over b, and represent fractions on a number line. And actually, it's not everything. There's more, okay? So the relation between the size of a fraction and the size of a segment on a number line, the equivalence of fractions. All of a sudden, we have a half and 2 quarters. It's the same number, maybe it's a different number, but they're equal. What does it mean? And I'm not done. There's more to the 3rd grade curriculum, okay? We also have, for example, to understand now that the whole numbers, okay, like 3 or 6, which we thought we understood now are also 3 over 1 or 6 over 1. They're also fractions. And yes, that's the result, I think, for most children. And one of the remedies to that is what I call feeding ahead. And game-based learning really gives us a lot of opportunities for doing informal learning of advanced concepts before they formally happen in school, in the same way as children were exposed to counting before coming to school. So if I was referring to fractions, Matific has a few dozens of games that all expose children to fractions, and it could happen at a very young age, like here making a necklace so that exactly a half of the beads are round. Or you have birds, you have cells, and place birds in 1/3 of the cells, and so on and so forth. As I said, about a few dozens of such games that are all expose children to use naturally fractions before it enters into school. But I don't want to give the impression that it's all about early age, so let me take something more advanced. Arithmetics with positive and negative numbers. Okay, so here is an example of what I call survival mode. What is 8 minus negative 12? Oh, I have no idea what it means, but negative is positive, so it's the same as 8 plus 12, it's 20, done. I have no idea what it means. So what I'm showing you here are screenshots from a game, and that's the setting. We have this hotel built on a cliff, and the entrance is at ground zero, is somewhere in the middle. So we have the positive floors and the negative floors, and the child playing the game helps, the elevator is broken, and the child helps the bellboy to do his work. So that's an example of a warm-up question. We are at the ground floor. We have to go to floor negative 12. And the question is, how many floors down do we have to go? That's an relatively easy question, right? And it's all interactive. The child can actually navigate in the hotel, go up, go down, see what's going on in each floor. There are a lot of surprises in this hotel, by the way. So if a child made a mistake, for example, and answered 5, they will go to floor negative 5, as they asked for, and of course, it was a mistake. So you get cursed by the guess that you've just woken up. Eventually, I got to floor negative 12, and now the question is, a guest on floor 8 needs you to pick up some dirty dishes. How many floors do you have to go up from negative 12 to 8? And if it reminds you about 8 minus negative 12, it's not a coincidence. Okay, that's a hands-on way to see and do arithmetics with both positive and negative numbers. By the way, if you make a mistake the first time, you get cursed. The second time, you actually get a visual hint. It shows you that you are at negative 12. You have to go to positive 8 plus 8. There's a 0 in between. How many floors do you have to climb? So once again, after seeing a game or games, some reflections. First, this game definitely gives you a very informal glimpse into integer arithmetics. I claim that it's accessible even to second graders, okay? Because by the end of the day, you can reduce everything to doing arithmetics with positive numbers. The setting is actually very natural. A lot of children, for example, at the mall, you have an underground parking at a negative floor, and you have to go up. There's an elevator. To many children, that would be very natural. Once again, I always look at what happens when you make an error. And once again, errors are both funny and instructive. Instructive because if you gave a wrong answer, you will actually go to where you asked to go and see that you've made a mistake. It's not a teacher telling you or a computer telling you it's a mistake. The third pain point I'm going to talk about is problem solving. So first, what is problem solving? It's basically the ability to combine previously acquired knowledge, techniques, skills, strategies for solving new problems. It's something that's prominent in every curriculum in the world. And yet, we apparently do a very lousy job in teaching it. According to a PISA report, a recent PISA report, in the OECD countries, more than half of the students cannot solve anything that's more than basic. So a few words about why it happens. Why do we fail in teaching problem solving? So one reason I believe is our own misconception. A lot of teachers, adults generally, have a feeling that primary school mathematics is just too simple to do serious problem solving. You have to learn, acquire basics, and only then you can do serious mathematics. And for everyone who thinks so, go on. I have a problem for you, okay? You have three vessels, one of 8 ounce, which is full, and then an empty 5-ounce vessel and a empty 3-ounce vessel. And you can pour fluids from one vessel to another, but there are no gauges. So the only thing you can actually do is either completely fill out a vessel or completely empty a vessel. And your goal is to divide the fluid into 2 equal parts. Okay? After my lecture, go and do it. It's not easy. Actually, it's quite difficult. But the point is that in terms of what knowledge do you need, add and subtract between 0 and 8. That's it. It's all knowledge that you acquired at the age of 6. And yet, we have the ability to really challenge you in something difficult. Another cause, I think, is a lack of resources. So, for example, thinking of the question you've just seen, many people would say that, yeah, great, wonderful, but can you do more of those? So I think there's a lack of resources, and also a lot of people confuse problem solving and word problems, like back again to Julia and her necklace, which is absolutely not the same. And finally, I think we have an issue of overprotection. You cannot learn problem solving, this skill, without being on the way many times, confused, fail. It requires a lot of patience. Return to a problem that you didn't solve, try again, and also being happy when you make even sometimes a very small progress. But in education, unfortunately, confusion and failure are always viewed as threats, something which will cause a low self-esteem and will actually get children avoid mathematics and science altogether. And that's where game-based learning really has very strong advantages. Okay, it gives a lot of opportunities to do real problem solving in a non-threatening environment. And remember, when children on their phone or whatever, they play games, for them, easy is boring, difficult is fun. And that's what we want. So I'm just going to show a bunch of screenshots from Matific activities that all do problem solving at various ages. That's for very young age. You are supposed to construct a village on some planet, and with 3 doors, in this case, 7 windows and 4 flowers. Okay, it takes some time. Okay, the arithmetic is basic, but solving the problem is less basic. And that's another screenshot from a game about strategies, all kind of river crossing riddles. Doing geometry, okay, maybe I give you an impossible task and you have to realize it's impossible. Logic riddles, okay, in this example, you have 3 streets and you have to place in each street a house and a dog. And for Mika's house is not on Amarillo Street, and the dog who lives in the greenhouse often visits Reno, and so on. And you have to solve the problem, okay, definitely developing logic capabilities. And let's stop on this one, for example, okay? It's a game that is a preparation for algebra. The task is a little Indiana Jones-like task. You have to steal the ring by placing on the scales hearts, the right number of hearts, to balance this yellow shape on the other side of the scales. And if the scales get unbalanced, the gorilla will wake up and you will lose. Okay, and if you look at the left upper side of the screen, it says level 2. Okay, so it's a multi-level game. I think there are something like 16 different levels, and that's still the basic levels. So how do we know how many hearts to put here? we go to the side and we see in this example, okay, that the purple shape is the same weight as two hearts, and a heart plus a purple shape is like the yellow shape, and therefore we can now do manipulation and like solving equations, and eventually get the conclusion that 3 hearts will balance the yellow shape. We go back, switch the ring for the 3 hearts, we won, and we go to the next level. Okay, so again, it's an informal way of doing problem solving, which is a preparation to doing algebra at a higher grade. Once again, some reflections on the games. So first, there's really many genuinely challenging problems that children can learn from and solve. The fact that it's a game neutralizes the anxiety. As I said before, difficult is fun. Applicable to all grades. You can start at the age of 5, do significant problem solving, and if we wanted to tell our children that math is not boring, that's the way. This is exciting. And we offer here a solution to chronic pain in math education, as testified by so many reports in every country. All right, I cannot finish my lecture without the yes, but clause. Can we really base math education on games? So I will quote here 2 of the greatest mathematicians of the first half of the 20th century, David Hilbert and Godfrey Hardy. For them, math was a game, so there was no question. Of course, doing math is playing. But remember, we are under the yes, but title now. I agree that doing mathematics involves also other things that maybe are not well done with games. Okay, collaborative learning maybe doesn't work well with games in which you play by yourself. An important part of mathematics is to learn to explain yourself, argumentation, and also addressing criticism. Someone tells you you did something wrong, you have to argue, to explain. Maybe you did a mistake, you have to understand it. And I truly believe that education in general, and math in particular, really requires both the professional and the emotional support of teachers. And yet, I still think that the potential of game-based learning is underexploited. So we talked about the fact that game-based learning provides fun, a safe environment, a good platform for seeding ahead the early assimilation of new concepts, and a good platform for offering good problem solving. But there's more to it. I think that through games, you can introduce new concepts in a very sound way. It's a very good platform from transitioning from the concrete to the abstract, which is something that happens all the time in mathematics. The children are active in their learning, which is critical to really learn and remember. And also, it's a very natural environment for personalized learning. Different children in the same classroom could play the same games, but at different levels. And yes, every curricular topic is playable. So Matific has above 1,500 games. I'm not going to show 1,500 screenshots, only 16. Just to give you the idea of how diverse games can be and how they can address every subject in your curriculum. Okay, so just 16 pictures from Matific activities just to display the richness of those activities. So what is the take-home message? We're almost done. That game-based math learning has the potential to engage, invoke curiosity, develop creativity and problem-solving skills, implant new concepts, and help transition from the concrete to the abstract. But it also has the potential to consolidate bad practices and reinforce the already excessive procedure-based learning. And if we come back to the beginning of the lecture, remember that for the gold medal, you need very good content in a very good game environment. Thank you very much. I hope that first you enjoyed the lecture and also it made you think about the profession of teaching mathematics. Goodbye.